I am Sadanand from the Department of Electronics. Today I am going to take the topic Digital Electronics for the second PUC students. In this one, 19 marks will be the second PUC final exam. 1 marks, 2 questions. Essay type questions will be 3 questions will occur. Okay. Now, what we have in this Digital Electronics, logic functions. The logic functions is what we declare as a logical state. That means it should have either 0 or 1 state. That is the digital electronics. That is what we have, the Boolean algebra concepts. There will be no intermediate state. There will be no intermediate state, either 0 or 1, do or die, true or false, like that what we have the functions. So, the logic gate is what we have is 0 or 1. If you consider the LED, that is the light emitting diode, it should on means we declare as 1. If it is off means we declare as 0. So, the waveform for this one is what we declare as a square wave. Okay, what we declare as a square wave. We can't consider the sinusoidal waveform because in that cases the real part will appear. In this case, either we have the 1 state period and the 0 state period. For all the digital electronics parts, we should consider only this square wave. Okay. So, logical gate, logic function, it should have either 0 or 1 state. That is, if you consider the LED lamp or any bulb glows, we consider as on. If it is off, we consider as 0 level. Okay. Again, we are considering with respect to the waveform, that is the square wave. If it is 0 means this state. If it is 1 state means it is a high state. Okay. So, this is about the logical functions. So, keep it in your mind, logical function means it should not have the intermediate state. That is like what we have the real part 1.1, 1.5, etc. There will be no real numbers. Only we have the zeros and 1. If we have the high voltage, we treat as 1. If it is low voltage, we treat as 0 level. Okay. So, 0 level and 1 level. Okay. So, in that one, what we have the logic functions. In the logic functions, we consider with respect to the mathematics as logic functions. When we get into the electronics part, we declare that it is a logic gate. So, the logic gate is nothing but the current flow through the bus according to the functions. At that time, they will change this function as logic gate. In that one, they will divide as basic gates, exclusive gate, universal gates. Okay. The basic gates, what we have is the AND gate. Number 2 is OR gate. Number 3 is NOT function. Okay. All should be written in the caps. Okay. AND gate, OR gate, NOT gate. Okay. Basic gates are AND, OR, NOT. Okay. Exclusive is represented as XOR, XNOR, XOR and XNOR. Whereas universal gates we have NAND, NOR. Okay. So, these are the different types of the gates which occur in your syllabus. One is AND gate, OR gate, NOT gate. Exclusive gate, XOR, XNOR. Universal gates, NAND, NOR. Okay. Again, once again I will recall logical function. Logical function means either it should have 0 or 1, either off, on when the bulb glows. When you get into the waveform, we say that one 0 or 1. So, digital part we take only the square wave. There will be no other wave should be considered. Okay, square wave will be used. Again, from the logical function, we get into the logic gates, that one we have the basic gates, exclusive, universals. So in the basic gates we have AND gate, OR gate, NOT gate. Exclusive are XOR, XNOR, universal, NAND and NOR. Okay. So now we explain what is AND gate. Okay. And AND gate, what we have is the symbol is just an elongated D. So this represents what we declare as AND gate. This elongated D represents what we declare as AND gate. Left hand side what we declare as input, on the right hand side what we declare as output. So A, B is the input and output is what we declare as Y. This equals to A dot B. This dot represents what we declare as AND function. Okay, this dot represents what we declare as AND functions. Okay, that is also called as multiplicative gate. Okay, it is also called as a multiplicative gate. So A dot B is what we declare as AND gate. So any number of input, let it be A, B, C, etc. At that time A dot, B dot, C dot, etc. Okay, so we have any number of inputs. Okay, so there is a general question. A logic gate is what we declare as any number of input but only one output. Okay, any number of input but it should have only one output. So AND gate is what we declare as A, B, Y is equals to A dot B. OR gate, in the same manner, the symbol will be slightly differs. A, B. So Y equals to A plus B. This plus represents what is known as an OR function, that is called A or B. Okay, that plus represents here in the digital electronics is called as OR function, A or B. Okay, NOT gate, what we have is the just one input, one output, what we declare as NOT gate. This is the symbol of NOT gate. A, Y equals to A bar. So in any manner we just call it as A bar. The NOT gate is nothing but an whatever the input is 0, the output is 1. Okay, whatever the input is 0, the output is 1, or if it is 1, it is 0. It is just a your TV remote control. Okay, in the power switch button, what we declare as if it is on, you just press it, means if it is off. If the TV remote button, if it is off, suddenly if you switch on, at that time on. That is nothing but the function of this NOT function. That is just opposite of that one. If it is 0, it will declare as 1. If it is 1, it is 0. So this is called what we declare as complementary gates. Okay. So this is about AND function A dot B, OR function A plus B, NOT function A bar. Okay, Y equals to A bar. That is the complement, Y equals to A bar. Okay. So the truth table, what we say is all the input possibilities with respect to the output. The truth table which gives you what is known as then all the input combinations with respect to the output. So the truth table which gives all the possibilities combination of input to the output. For example, AND gate. How many inputs we have here? 2 inputs, right? So at that time we should have one simple concept, 2 to the power of n. N represents n number of inputs. So here how many inputs we have? 2. So that is we have the 4 combinations. So that 4 combination is nothing but an 0 0, 0 1, 1 0 and 1 1. Okay. So the AND functions A B, is it right? A dot B. That is, and beginning I told you that one, it is a multiplicative. That means 0 dot 0, it is 0, 0 1 0, 1 0 0, 1 1, it is called 1. Any number of 1, okay, any number of 1 input, it fetches you only the 1. That is the concept of the Boolean algebra. Okay. So you take the OR gate. It is also the same combinations. Okay, according to this rule, 4 input will appear. So I will extend the truth table with respect to the OR functions, that is A plus B. This plus represents nothing but the OR functions. So 0 plus 0, 0, 0 plus 1 is 1, 1 plus 0 is 1, and 1 plus 1 is 1. So the Boolean function always it takes as 1 plus 1 as 1. Any number of 1, it will be taken as 1. So that is what we have the OR functions. In the case of a NOT gate, it just what we have is A and A bar. So it has got only one input 0, output as 1. 1 means 0. So this is what we declare as NOT function. Okay, this is called NOT function, that is 0 and 1. If it is 1, the output will be declared as 0. Okay, so what we have is the NOT function. 0 means 1, 1 means so 0. Once again I will call you that AND function, OR function, NOT functions. AND gate 0 0 0, 0 1 0, 1 0 0, 1 1 1. The OR function 0 0, output will be 0, 0 1 1, 1 0 1, and 1 1 it fetches you 1. Whereas the NOT functions, it is complementary. Whatever you give, just opposite in nature, either that is 0 to the 1 and 1 to the 0. Okay, this is about exclusive gates are XOR and XNOR. Okay, in this case XOR, the symbol will be written in this form. Just like an OR gate, an inverted C is what we declare as XOR functions. So the inputs are AB on the left hand side, output will be written as A XOR B, that is OR function within a circle, that is what we declare as XOR function. The truth table for this one is what we have is 0 0, we have that 0, 0 1 1, 1 0 1, 1 1 0. That means if we have odd number of ones, then the output will be 1. If it is even number of 1 or zeros, at that time the output will be 0. So this is especially mainly used for the calculators. Okay, from this one we have get into this what we known as the digital adder circuits. So XOR function is a very important functions. In the case of an XNOR, the same manner, just complement of this one. So A just of AND function within the circle. Okay, just you think of the XOR gate, here also XOR gate. This bubble represents what is known as an XNOR function, just the change of this O to N when we put the bubble here. Okay, that is nothing but an A XOR B whole thing to the bar. That represents what we declare as A dot B. Okay, this is called XNOR. Just opposite to that one, just what I discussed in the basic gates, it's a complement of that one. So what is 0 complement? It is 1. What is 1 complement? It is 0. What is 1 complement? 0. What is 0? It is 1. So this is what we declare as XNOR functions. Okay, XOR and XNOR. So XOR is widely used for the binary adder circuits. XOR is mainly used for the binary adder circuits. Gates, what we declare as NAND and NOR. It's nothing but a combination of AND gate and NOT gate. NOR gate is nothing but the combination of NOT plus OR gate. Just you remember the symbol NAND, AND gate plus NOT gate. So combine this one, take the symbol as elongated D, okay, and the bubble of NOT gate. This fetches you what we have is the NAND gate. Okay, A y equals to A dot B whole bar. y equals to a dot b whole bar. Okay. So a b output will be a dot b whole bar. NOR function has the same case as OR gate plus NOT gate. Now just you take the OR gate, next the bubble you take here, this fetches you what you call as NOR function, a b, that is a plus b whole bar. Okay, this is the complement. Okay, y equals to a dot b whole bar, a plus b whole bar. As the same case of AND function, OR function, complements. This fetches you what is known as an NAND and NOR gate function. Universal gates, why we call it an universal gates, means we can derive all the basic gates using this NAND and NOR. Okay, so that is why it is called as NAND function and the NOR function. So we can realize all the basic gates, all the exclusive gates and the universal gates. Why? That is why it is called as an universal gates. Just you think of the truth table. Once more I will write the symbol, just an AND gate, write the bubble here, then it forms to AND 2, converts to the NAND. At the same case NOR, just you write a OR function, just you take a bubble here in the output, then it is called a NOR functions. So I will write the logical functions y equals to a dot b whole bar. Here I will write a b, y equals to a plus b whole bar. Now you take the truth table. Again it has got the 4 combinations according to what we had discussed in the beginning. A b 0 0. What is here? We have a dot b whole bar. A dot b whole bar. 0 1 1 0 and 1 1. Now according to this one, 0 into 0, what it fetches you? 0. But here it is complemented, then the output will be 1. 0 1, again the complement is 1. That means a dot b is 0 into 1 is 0, but here we have the complement, it fetches you 1. Again in the same manner 1. Here AND gate function is 1 1 is 1. Is it right? 1 1 is 1. Again the output is complemented, so we take it as 0. So this is what we declare as NAND function. Okay. In the same manner you take as the NOR functions, a plus b whole bar, a plus b whole bar. So in this case OR function, right? So 0 plus 0 is 0. Okay, that is 1. 0 plus 1 is 1. If you take the complement is 0. 1 plus 0 is 1. Complement is 0. 1 plus 1 is, output is 1. The complement is 0. Once more I will discuss NAND gate symbol, elongated D and plus the bubble represents what is known as an NAND function. NOR gate, OR gate plus bubble represents what is known as an NOR functions. NAND and NOR is called universal gates. The truth table, A, B represents the input, the output is A dot B whole bar. Here A plus B whole bar. So NAND function is 0 into 0, that fetches you 1. 0 1 1 1 0 1 1 1, it is 0. In the case of an NOR function, 0 0 1 0 1 0, irrespective of everything is 0. This finishes what we have, the basic gates, exclusive gates and NAND gates. So today what we had discussed, the whole thing, that we had given the assignments. Okay. So in the assignments what we have, the write the symbols and the truth table of basic gates, exclusive gate, universal gates. This may be up to the 5 marks. Okay. Define logic gates, 1 marks. What are the uses of XR gate? Okay. You write it neatly in a book and upload to the link provided. Thank you. Stay home, stay safe.